So if we start by trying to find f of g of x, we're going to take g of x and substitute it in to f of x. So wherever we see an x, we're going to replace it with x squared minus 3. So right there, we're going to have x squared minus 3 squared plus 2. All right, to square x squared minus 3, what do we have to remember to do? FOIL. So don't just tell me that it's x to the 4th plus 9. That's not right. Because if you FOIL this out, you get x to the 4th minus 6x squared plus 9. So don't forget your OI and your FOIL. And then we still got that plus 2 trailing afterwards, which if we combine our like terms a little bit, x to the 4th minus 6x squared plus 11. So then for part B, we're looking for g of f of x. So this time we're going to take the x squared plus 2 and substitute it in our function g. So we're going to have x squared plus 2 squared minus 3. So again, we've got to remember to FOIL that. So we'll get x to the 4th plus 4x squared plus 4 minus 3. And then if we combine our like terms just a little bit, we get x to the 4th plus 4x squared plus 1. All right, so now we want to find f of g of 2. Are we feeling confident that this is good? I think so. All right, so we're going to replace each x there with the 2 instead. We'll have 16 minus 24 plus 11. So 27 minus 4. I think that works out to be 3. So any questions with our second pair of functions here? All right, how are we feeling so far? Any ones, twos, threes, fours, fives? All right, so now we're going to look at everybody's favorite. What do we love? Fractions. Fractions. All right, so if you see fractions, fret not. They're not, the root of all evil like you guys seem to think. We've got f of x equals 2x minus 3 and g of x equals x plus 3 over 2. So same deal. We want f of g of x, g of f of x, and f of g of 2. Okay, so if we're first looking for f of g of x, we're going to take our delightful fraction here and substitute it in for x. So we're going to have 2 times x plus 3 over 2 minus 3. What's the furrowed ground for you?
I don't know.
It's easy because
Can we cancel the 2's?
Yes.
Yeah, because that 2 is being multiplied by that whole top, we can cancel it out. So then we'd have x plus 3 minus 3. So it's just x. See, I told you not all fractions are bad. Most of them aren't. All right, so now for part B, we're looking for g of f of x. Alrighty, so we're going to take our lovely 2x minus 3 here and substitute it in for x in the top of our fraction. So we'll have 2x minus 3 plus 3 over 2. So, yeah, those 3's would cancel. And we'll get 2x over 2. Now those 2's cancel. And jazz hands, we get x. Alright, so notice this one's a little bit different because they both simplify down to the same thing. At a later date, that's going to be really, really special and really, really important. So notice good things happen for us when this works out. So later these two functions are going to be pretty important, kind of a big deal. But for now, just notice that sometimes that happens, and when it does, it's a good thing. All right, so then what would f of g of 2 be? Thank you. Yeah, if we substitute 2 right in there for x, whew, that was a lot of work. It happens. We've all been there. All right, so any questions with this pair? All right, so these were pretty, or excuse me, that was a pretty nice fraction because it didn't have a variable in the denominator. We're gonna look at one more pair here, where again there are fractions, and again you guys are thinking, oh, so much worse than what it really is. It's not that bad. So same deal. We want f of g of x, g of f of x, and f of g of 2. And this time our f of x equals x over x plus 1, and g of x equals 4 over x. So for f of g of x, we're going to take this little fraction and substitute it into the bigger fraction. But there's more than one x this time. So this is the first time we've seen that. If there's more than one x in the function that you're substituting into, each x gets replaced with that other function. So our 4 over x is going to go into the top of our fraction, and it's also going to go into the bottom of our fraction. So each x you see gets replaced. So we're going to have 4 over x that we're substituting in. So we'll have 4 over x over 4 over x plus 1. If you've got 5, oops, there we go, over 5 plus 1.
No,
Can we cancel those?
plus 1 on there.
Yeah. Doggone addition messing us up here. So, am I going to let us leave an answer like that?
No.
Of course not. We can't have compound fractions. We don't need fractions in fractions. But there's a really easy way to make them go away. If we look at all of our fractions, what would our least common denominator be? Not just denominator. Well, what denominators do we see? X. So between these two fractions, well, it's the same fraction, so they both have a denominator of x. So what would the least common denominator between x and x be? X. So if we multiply that least common denominator into the top and bottom of our fraction, it's going to make, it's not so much that it cancels, yeah, it's going to make our, or did you mean this or here?
There.
Yeah, it'll get rid of those denominators for us. And we're allowed to multiply by x over x, because way back in the day we talked about the identity property for multiplication, where we're just multiplying by 1. It's a squirrely looking 1, but it's just 1, so it's no big deal. So we take 4 over x and multiply it by x. What happens?
X is cancelled.
Right, so it's just 4. Now here, easy mistake to make sure you distribute your x in the bottom. So 4 over x would just be, oops, not x, hello, 4. But then we do need to remember to multiply that 1. So it's just x. Can we leave it like that?
Yeah.
Absolutely. So if you have compound fractions, just multiply by that denominator, and it'll go away right away, and it's no big deal. All right, so now we still need to find g of f of x. So now we're going to be taking our big fraction and plugging it into the denominator of our little fraction. All right, so we're going to have 4 over x over x plus 1, and that looks nothing like 1. Let's try that again. All right, so what are we really doing here? We're dividing by a fraction. How do we divide by a fraction? I think I heard it really quietly. Yeah, we multiply by its reciprocal. So we're going to take the 4 and multiply it by the reciprocal of our denominator, to be x plus 1 over x. So if we just distribute the 4 to the top, we have 4x plus 4 over x. And it's good to go. So even though this one had more, I would say much more complex fractions, still really not that bad. So then one last piece. We need to find f of g of 2. So we're just going to take 2 and substitute it right in there for x. So we get 4 over 6, and what does that simplify to? 2/3. So again, fret not if you see a fraction, it could still do just fine. I would say these are complex fractions, and how hard was this? Come on. I would say it's one of the easy ones we did. Easier than those squares. All right, so any questions with our last set here? All right, overall, what are we thinking so far about function composition? Any ones? 2s, 3s, 4s, 5s. Marvelous. All right, so we'll talk more about these tomorrow. Particularly tomorrow, we're going to worry some more about domains. Just wanted us thinking about those a little bit today.